In the late 19th century, a young and brilliant mathematician, William Clifford, began shaping ideas that would challenge the very foundations of science. His work hinted at concepts far ahead of its time, bold, visionary, and radical. But Clifford wasn't just developing abstract mathematics. He was laying out a framework that reimagined the fabric of reality itself. His revolutionary insights suggested a deep connection between mind, matter, and geometry. Ideas that seemed more like science fiction than serious science, both to his contemporaries and even many today. Some now regard his theories as a forgotten blueprint for the elusive theory of everything, a vision of physics fundamentally reshaped by the language of geometry. Others dismiss them as mere echoes of Einstein's later breakthroughs, overshadowed and buried by the rise of mainstream scientific thought. Yet, what if this overlooked body of work holds the missing pieces to modern physics' greatest unsolved mysteries? What if the struggle to unify quantum mechanics and gravity and the enigma of consciousness and space itself stems from one fateful mistake: ignoring Clifford's path? This is the story of a theory abandoned, a future foreseen, and a scientific revolution yet to unfold. Physical science describes how matter behaves, but rarely explains what it is at its core or why it exists. At the heart of these profound questions lands Panpsychism, a theory suggesting that a mind-like essence permeates everything. There's nothing supernatural here. It's a bold proposal that matter can be understood in two ways. In this context, Clifford introduced his original and intriguing concepts of the matter of mind, or mind stuff, and eject. Another contribution, now known as the complex Hopf vibration, is seen by some as essential for understanding how consciousness and matter are intertwined. Tragically, the young genius died early, nearly taking his groundbreaking geometric algebra with him. Unbeknownst to many, Dirac and Pauli later reinvented parts of his work for quantum mechanics. And today, Clifford algebras underpin gauge theories and gravitational models. But Clifford is almost unknown for his deep philosophical ideas. He reasoned that if humans, the most advanced known minds, are conscious, and even simpler organisms show signs of intelligence, then non-organic matter must hold the seeds of mind. In his view, every atom carries its own atom of mind stuff. Matter itself, he proposed, is mind stuff, a hidden essence that becomes more complex as life evolves, reaching its peak in human consciousness. Modern researchers are exploring a similar concept, the notion of a minimal agency in nature. This agency that links consciousness and matter, responsible for storing and processing information, might be the key to understanding how consciousness emerges. For example, this article states, "Agents are just creatures that can learn about the world and use what they learn to change and control it. They must include some element of memory storage and recall, the ability to bank and process external information over time." It's intriguing how these agencies align with Panpsychism, a theory gaining renewed interest. Tracking back to Democritus, Giordano Bruno, and even prehistoric thought. The next article revisits this ancient philosophy through a modern lens. According to Panpsychism, consciousness pervades the universe and is a fundamental feature of it. This doesn't mean that literally everything is conscious, but rather that the fundamental constituents of reality, perhaps electrons and quarks, have incredibly simple forms of experience. After all, as we move to simpler forms of life, we find simpler forms of experience. So it's at least coherent to suppose that this continuum of consciousness carries on into inorganic matter, with fundamental particles having unimaginably simple forms of experience. In other words, if a minimal agency or mind stuff begins to manifest at the level of subatomic particles, they might carry a faint trace of experience, a proto-consciousness. In our standard view, consciousness appears suddenly in complex brains. But Panpsychism paints a different picture. Even electrons or quarks might have a hint of experience, however rudimentary. The complex, layered experience of a human might simply be the culmination of countless simple interactions, a vast mosaic of mind stuff. Clifford defined mind stuff as follows, quote, "That element of which, as we have seen, even the simplest feeling is a complex, I shall call mind stuff. A moving molecule of inorganic matter does not possess mind or consciousness, but it possesses a small piece of mind stuff. The elements of mind stuff which go along with them are so combined as to form the faint beginnings of sentience. When matter takes the complex form of a living human brain, the corresponding mind stuff takes the form of a human consciousness, having intelligence and volition." This profound idea that the entire universe might be made of mind stuff resonated with later scientists. Nobel laureate Wolfgang Pauli, for example, saw no clear line between the physical and the psychical. In Clifford's view, hidden aspects of matter could emerge in our intuitive moments, when answers seem to shine through consciousness, like an informational hologram. It's as if there were hidden channels in our brains, shortcuts that bypass linear computation and let us grasp truths in an instant. That's the possibility Clifford hinted at. As a mathematician, he proposed that matter might simply be hills of space curvature, with waves propagating through these curves. In other words, matter is nothing more than variations in the shape of space itself. It can be imagined as a sheet of paper being folded and twisted. The creases and ripples represent forces like gravity and magnetism. Clifford's algebras described these folds, offering a bridge between geometry and physics. He predated Einstein by nearly half a century, and Clifford's vision even anticipated key ideas of quantum physics, such as superposition and the wave-like behavior of matter. Yet his notion of mind stuff remained largely overlooked. A breakthrough came with a groundbreaking article by physicist-mathematician Sir Roger Penrose, co-authored with neurobiologist Stuart Hameroff.
And I want to present the point of view that I've had for some while, although modified in various ways, which is that consciousness is not the result of computation, it's something else. So I want to try and explain why that's not the case.
Penrose argued that intelligence requires understanding based on immediate intuitions, not just calculations. He linked these intuitions to quantum processes occurring within these tiny corn-shaped structures, microtubules inside brain cells, where they form vast interconnected networks. Although critics argued that the brain is too wet and noisy for quantum effects, growing experimental evidence suggests robust quantum effects in microtubules. Penrose's theory suggests that every time a particle shifts from a quantum to a classical state, it experiences a moment of proto-consciousness. And in these very moments, matter appears to observe itself.
Let me very quickly say, if the thing's in one place or another, the universe has to make a decision. It's because the space-time of that tiny little mirror, if it's in one place or in the other place, they're slightly different. The two gravitational fields are slightly different. And space-time doesn't like to be in a superposition of two places at once. That's the sort of argument. So it decides on one or the other. Now that decision that it makes to one or the other is what Stuart and I refer to as a moment of proto-consciousness. See, the idea is that the universe has to make a choice. Now, it's totally unimportant as far as the universe is concerned which choice it makes, so it's effectively random. But if you have this choice somehow at a much bigger scale and tied up with all sorts of other processes which are meaningful in one way or another, then that is the kind of choice that one actually makes with a conscious decision. So it's not that this is conscious, I'm not even saying that. That's why we say proto-conscious. It's the sort of brick out of which the building of consciousness is constructed. So the idea is that consciousness needs a lot more.
As matter becomes more structured, like in the brain, something remarkable happens. What Clifford called mind stuff starts shaping conditions for consciousness manifestation. Penrose describes this manifestation as qualia, the raw feeling of experience emerging when quantum processes inside matter reach just the right conditions. But other scientists, like Princeton's Max Tegmark, suggest a new way of thinking about the connection between consciousness and quantum mechanics. Instead of asking, does quantum mechanics explain consciousness? The author flips the question. Does consciousness help explain quantum mechanics? In simple terms, the brain isn't just influenced by quantum mechanics. It may also have something to offer in understanding how quantum reality itself is structured. Tegmark takes these ideas even further. His ultimate ensemble theory of everything proposes that all structures that exist mathematically also exist physically.
So I think the single most striking thing I've learned so far in my career as a scientist is that the ultimate nature of reality, whatever it is just much weirder than we thought, much more different from what we thought it was than people in their wildest dreams would have imagined in the past. And in my mathematical universe, the book, I even go as far as saying our universe isn't just described by math, it is mathematical in the sense of being a mathematical structure. By which I mean that our universe doesn't just have some mathematical properties, it has only mathematical properties, much like a computer game. If you're in a computer game, there is no actual stuff in Pac-Man, right? It's the entire nature of Pac-Woman or these little things you gobble up or the monsters or just relationships between abstract things that have no intrinsic properties at all. There's no actual stuff there. And in the same way, I think this is what we've learned about our physical world. It's the relationships that really, really matter between things in the world. And that's ultimately all there is. The entities themselves have no properties except the relationships that they have. That's not that different in some sense from our thoughts.
In his view, consciousness might be yet another state of matter, just as water is to fish. Interestingly, like the Penrose-Hameroff theory, Tegmark's approach to consciousness has roots in biology, drawing influence from neuroscientists, particularly Giulio Tononi. His research suggests that consciousness is not merely a byproduct of evolution, but emerges from a system's ability to integrate information. He proposes that consciousness arises wherever information is processed in a highly integrated and irreducible way. The significance of Tononi's ideas is that they can be expressed mathematically. This makes it possible for physicists like Tegmark to start working on detailed analytical models. His work highlights that matter holds an immense untapped computational power, far beyond anything our current computers can achieve. But is consciousness just computation? Or is it something more? Tegmark suggests that consciousness emerges not just from raw processing power, but from the way information is structured and integrated, just as the geometry of space-time shapes the force of nature, weaving the intricate patterns of experience. For instance, Tononi showed that for a system to be conscious, it must both store and integrate information in a unified way. This has led Tegmark to introduce concepts like computronium and perceptronium, terms that hint at the computational and self-aware nature of matter. Tegmark argues that for these substances to work, they can't just store and process information. They must do so in a way that creates a unified, seamless whole. They must have autonomy, meaning they can process information independently without constant external control. In other words, for a system to be conscious, its inner workings must be driven by forces from within, not just external inputs. Tegmark's ideas have intriguing similarities to Clifford's, but there's a key difference. Tegmark doesn't claim that all matter is conscious. Rather, he argues that consciousness emerges only in special configurations of matter, much like wetness emerges only in a water droplet, not in an ice crystal or gas cloud, even though they are made of the same water molecules. It's not the individual molecules or particles that make the difference, it's the pattern in which they are arranged. Clifford saw it differently. To him, mind stuff wasn't an emergent property. It was already there, embedded within every atom, every particle. Two radically different visions of reality. If Tegmark is right, consciousness is just a fleeting state, an accident of physics. But if Clifford is right, then mind stuff is everywhere, forming the foundation of the entire fabric of the universe's space-time. These are compelling theories. But how do we test them? How do we know they're real? Some quantum effects in the brain have been experimentally confirmed. But the most intriguing piece, the elusive mind stuff, remains a mystery. What if we are missing an unknown fundamental physics here? As Penrose suggests, undiscovered laws of nature may be waiting, hidden principles that could finally reveal the true nature of mind stuff. And here's where things get even more intriguing. While mainstream science may sideline these ideas, secret research programs have taken a pragmatic approach. For decades, intelligence agencies have experimented with psi phenomena, like remote viewing, using what they call informational psi.
The general description of remote viewing is the capacity to describe a person, place, or location in great detail to which you have no access to generally other than through mental means.
According to this paper by the lead scientist of the CIA's Stargate project on remote viewing, they applied an informational psi program, resulting in hundreds of separate military and intelligence missions. An extensive review of the U.S. government-sponsored psi research program led to the conclusion that informational psi is a scientifically valid phenomenon. The sessions produced useful intelligence, with 17 out of 19 agencies returning for more remote viewing reports. Such a high return rate suggests the information was way more than just imagination, unless 17 government agencies were all in on the same hallucination. Furthermore, in Clifford's mind stuff framework, another anomalous phenomenon would receive an intriguing interpretation. If mind stuff truly underpins the universe, then phenomena like psychokinesis might not be about applying mysterious forces, but about tapping into the inherent intelligence embedded in matter itself. After a century of detours, science is circling back to ideas once dismissed as fringe, ideas that led straight to Clifford's forgotten path. His path suggests that consciousness isn't a late arrival, but the very medium of existence, woven into every atom of the universe. In the 1970s, renowned physicist John Archibald Wheeler gathered top minds in a Princeton conference celebrating 100 years since Clifford's renowned lecture. The theme was, "Where do we stand today? And what developments can we look forward to on Clifford's vision of particles as made of curved, empty space?" But remember, Clifford never saw space as empty. He emphasized the ether, the matter of space, as crucial for unifying all natural phenomena. Some argue ether is outdated, made obsolete by Einstein's relativity, but many scientists have suggested a revisiting of the concept since then. Paul Dirac, one of the founders of quantum mechanics, argued that bringing back ether as a dynamic structure aligns with relativity and benefits physics. Nobel laureate Frank Wilczek took it further, proposing a dynamic ether, acting as a superfluid and superconductor, as the hidden sea of waves and patterns from which energy and matter emerge. Now, the key puzzles to understanding the connection between geometry, matter, and mind were in place 2 centuries ago. Our challenge now is to assemble them. Are we ready to bite the bullet? To step away from the comfort of accepted science and take the harder path forward? Only by daring to climb higher can we see the universe not just as matter in motion, but as something alive, a hidden order flowing through the very fabric of mind stuff. And perhaps from there, we'll uncover something far greater than we ever imagined.
To me, though, what's most exciting about our universe, and also philosophically and emotionally and spiritually most empowering and interesting about it, is that through us, our universe has actually become aware of itself.
Aware of itself, yeah.
First self-aware entities appeared. That's, in a sense, our universe waking up and becoming aware of itself, right? We know it happened here on this planet. Maybe it's happened elsewhere. In any case, I think that's the most important thing that's happened so far. Because if you look at all these laws of physics, they don't say anything about beauty, meaning, or purpose. And I think one of the most inspiring things for me personally to think about is, what can I do to help our universe wake up more?